Okay, generally speaking, in this course, we're going to use a two-column proof to do almost all the proving that we do. But I do want to make you aware that there are other formats of proving things in case you happen to see them used, or even if I happen to prove something this way in class, you're not thinking that this is all crazy. I'm going to show how to use a flowchart proof by proving what's called the angle bisector theorem. Okay, so the angle bisector theorem basically says that if I have an angle and I have a bisector, so let's say this is the angle A, B, C, and I have a bisector, ray BX, that each of these angles will be half of the whole. So that's what the theorem says, that in this case, if ray BX bisects angle ABC, then the measure of angle ABX is 1/2 the measure of angle ABC, and so too the measure of angle XBC is also 1/2 the measure of angle ABC. Okay, so that being said, we want to prove this, and the way we're going to do this is to use what's called a flow chart. So we have to first establish like what this gives us, right? So we're given that BX bisects angle ABC, and we need to prove that these two things are true, so that the measure of angle ABX is half the measure of angle ABC, and the measure of angle XBC is half the measure of angle ABC. Okay, so I'm going to need a little bit of space to do this, so what we're going to do is we're just going to kind of hold on to this, and we will create a new panel here, and I'm going to put the drawing back up in the panel, and then I'll draw out the flowchart proof. Okay, so I'm going to redraw the drawing over here one more time. So this is angle A, B, C with the angle bisector. Oops, that's not very good. With the angle bisector BX, ray BX. Okay, so what we start with oftentimes is our given information. And, well, we were given that ray BX bisects angle ABC. Okay, so that's a piece of information that I get from that. Now, I know that because it's a bisector, that these two angles have to be the same size. So that tells me that the measure of angle ABX has to equal the measure of angle XBC. Okay, so why is that? Because that's the definition of a bisector. Right? Bisector is something that cuts something into two equal parts. All right, so another source of information that I can have is the drawing. Right? So the drawing itself, I can draw a conclusion. I can say that the measure of angle ABX plus the measure of angle XBC is equal to the measure of angle ABC. Okay, well, that seems pretty logical. We've seen this before. The two angles have to add up to the whole. This is what we have called the angle addition postulate, is what allows me to do that. Okay, so I've justified this. Now, why did I do this? Because, see, I can use these two together. See, these two are equal, and they're both in here. So I can take that guy out, put that guy in, and I can say that the measure of angle ABX plus the measure of angle ABX is equal to the measure of angle ABC. Okay, so how did I get that statement? Well, it came from both here and here, and I used substitution to do that. All right, so here I can also kind of rewrite this. This is 2 times the measure of angle ABX is equal to the measure of angle ABC. Okay, so that's got me partway home there, right? Because if I got 2 times this and it's equal to that, then I divide both sides by 2 and I get the measure of angle ABX is equal to 1/2 the measure of angle ABC. And if you kind of look back in the notes on this and look at the previous screen, so if you rewind the video and you look at the previous screen, this is actually one of the 2 things that I'm trying to prove. So I've proven one of them. Yay. All right, so I did that by the division property, right? I divided both sides by the same thing, got the division property. Okay, so now I can play a little game here. As I know that ABX is equal to XBC, so I can pull these 2 together using, again, substitution and say now that the measure of angle XBC is 1/2 the measure of angle ABC, which is the other thing that I'm trying to prove. Now, this format of the proof is a lot messier and a lot more physical, but it shows you kind of the direct ties that each of the statements make to each other in proving our 2 conclusions. That we start with our given information, we get to our conclusions, so we've made a deductive chain of reasoning. The statements are all in the boxes and the reasons are along the arrows. Now, again, because of the way that things kind of work out, we're actually going to not use this form very often, but sometimes we may have to illustrate a point, and it's pretty useful so you can see where things came from. Okay, the other uncommon use of proof is going to be what we call a paragraph proof. And to demonstrate this, I'm going to start with a drawing here where I have A, and this is M, and this is B, and I got another drawing here where I have C and N and D, and we're going to give some information here. The information that we're going to give is that M is the midpoint of AB, so these have to be equal. And then we know that N is the midpoint of CD, which is going to make these equal. And what we're going to try to prove is we want to prove, oh, we also know one other thing. Whoops, take that back. Oh, these 2 are equal, right? But we also know this little fact that AB is the same length as CD. Okay, so we know that this and this have the same length. Now, what we want to prove, there we go, finally want to prove is that MB is equal to ND. MB is equal to ND. So this is the thing we're going to try to get through here. So remember MB and ND. And I'm actually going to look at the paragraph proof that's in your notes because it's a lot easier than just writing this all back out. All right, so if you look at your notes, here's the paragraph proof that actually does this here, right? So we're starting with a given. M was the midpoint of AB, so there's our drawing. M's the midpoint of AB. N is the midpoint of CD, so that's there. And AB remember, and CD are the same length. So that's what we're given. Right, so it starts off with that. It says, given that M is the midpoint of AB, segment AB, then we know by the midpoint theorem, which was like not this past notes, but the notes before, that MB has to be half of AB. And likewise, so if N is the midpoint of the other one, we also know by the midpoint theorem that ND has to be half of the other one. Now, since AB and CD are equal, because that's a given, right? They're equal, we can use the substitution property here, right? So we can now take out, because we know that AB and CD are equal, we can take out the CD here, right? So we can take out this CD, and we can put in that AB, which is what we did down here. So we have ND being half of AB, and up here we have MB being half of AB. So since they're both equal to half of AB, again by the substitution property, since they're both equal to the same thing, we can say that they're equal to each other. So this is what we were trying to prove, right? We were trying to prove that MB is equal to ND, right? And that's what we've got down here at the bottom. MB is equal to ND. So again, it's all the logic and all the reasoning, but not with the formal two-column structure. It's a completely legitimate way to do it. Not going to be a common way in our class, but just wanted to show you and make it real for you here. So there are other forms of proof. These include flowchart proofs and paragraph proofs. They have some advantages and disadvantages, but just want you to see them and to know that they exist. All right, thank you.